Not observing the diagram properly has resulted many of you doing this question wrong. First of all, you can see that this is a glass prism here. And in this diagram, we have to identify the first the angle of incidence, the angle of emergence, the next, and the angle of deviation, the last or the third. So let's see, if I talk about the angle of incidence, many of you actually take the incident ray as to be this, right, as it is. It's not true. Here the incident ray, as you can see, arrow properly indicated over here. So this is the incident ray here, and what we know as the normal, it is the angle made with the incident ray, and clearly P is the right. So P is the angle of incidence. First answer for this will be P here. And then what we have to identify the next here is the angle of emergence. An angle of emergence is the angle made with the emergent ray, angle made by the emergent ray with the normal. So this is the emergent ray, and this being the normal, this is the normal. So therefore the angle of emergence is Y. So angle of emergence is Y here. And finally, the what we have to identify is the angle of deviation. Well, the angle of deviation is what? The angle made with the incident ray produced forward and the emergent ray produced backward. So should have been this, but these are vertically opposite. They are equal only. So Z is the correct answer here. So Z is for the last part, right? So it was P first, then Y, and then Z, P, Y, Z. So option C is correct in this case. In this question, it says an angiosperm plant having a red colored flowers when crossed with the other having same color produce 40 progenies, right? Out of which, out of this 40, right, there are 40 progenies, out of which 30 plants are red colored. 30 of them is red. So 30 of them is red, and flowers, and 10 were white. So the remaining 10 were white, right? 10 plants were white flowers. Now, what we have to find out is this. The first one is, what is the possible genotype of the parent plants? So what we can see from here that the resulting progenies have a ratio of what? 30 over 10. 30 over 10, if you divide, what you are getting? 3 is to 1, right? This is 3 is to 1. Let me write down. We have this ratio as 3 is to 1. So 3 is to 1 is when? In the F1, and which is the possible result of what? Let's say I use capital R for the red and small r for the white, right? And so I can see that the possible color for has to be from this, right? From the dihybrid cross where R red is dominant. So check here on recombinations of this, it is what the zygote will have capital R can be capital R, small r, right? So first with first, and then first with second, and then second with first results to give you capital R, small r, and second with second will result to give you small r, small r. Now, red being dominant, this will be red being dominant. You can see that this will be red. This is homozygous red. This is heterozygous red. But then all of them are red, and the ratio is now 3 is to 1. Now, if I read the next question, it says which trait is dominant or recessive. So it's very clear that this red is dominant and this is recessive. This is F2 generation. And what is this cross called? And what is the phenotype ratio? Well, the phenotype ratio we have obtained as 3 is to 1, right? If they ask you genotype ratio, then genetic combination you can see is 1 is to 2 is to 1, but they are asking for the phenotype. And what is this cross? As I said, this is what? You can see that it is one pair of contrasting characters. So we said it's monohybrid cross, right? So mono is what? You will use monohybrid cross in this case. The question is what heat changes do you expect in the beaker? One has anhydrous copper sulphate. Anhydrous is what? Where the it is deprived of water molecules being attached. right? As you can see, anhydrous is there in one beaker, and hydrated copper sulfate is there in the other beaker. So all you have to remember that anhydrous copper sulfate uh, on dissolving water will absorb heat from the surroundings. So this is considered as an endothermic reaction. So we'll say that the temperature would fall in this case. Well, the other one, that is dissolving of a hydrated copper sulfate solution, is an exothermic reaction, and in this case the temperature would rise. That's what you have to write in the exam. The question here is that a person is suffering from short-sightedness, that is myopia, and can see clearly up to a distance of 2 meters. That means he cannot see any object beyond 2 meters. And what we know that that means he is suffering, his eye is myopic eye, and for a healthy eye or a normal eye, one can see up to infinity, right? And therefore, we say that the defect is this. Now, what we have to find out is the nature and power of the lens required to correct his vision. Now, check here. What do we do in this case? We take U or U and V, right? Before that, I should tell you the formula we are going to apply is that same, that lens formula, which is 1 over F is equal to 1 over V minus 1 over U. In this case, U is always the eye's ability, and for farsightedness, for longest distance to which a human being can see is infinity. But I'll take here U and V are taken as negative. Now, next is the distance up to which he can see is 2 meters. The defect is 2 meter. We'll be writing minus 2 meter. Now, replacing these values over here, what do we get? This is 1 over minus 2. So minus above, minus minus plus, and this is 1 over infinity. So 1 over F comes out to be minus. This is reciprocal of infinity is 0. So this is minus 1 over 2. So F comes out to be reciprocal of this, right? Yeah, F is minus 2 meter. But then we have to find out the power, and what we know, power is reciprocal of focal length. So P comes out to be minus 1 over 2, that is P is minus 0.5 diopter. This is what. And nature is what? It is easy to determine. As you can see, F is negative, even P is negative. So we say that it is concave lens. So nature is what? Concave lens. And the power needed for the correction is how much? Minus 0.5 diopter. It's a diagram given here, and we are asked to find out the equivalent resistance between them. Now check here, many of you has a confusion, right? Where from the current is flowing, obviously around to the end A and B, right? The current is and is along this AB. Now check here what I always say in this case, that if you wipe out this one register, you see current continues to flow in the other two. If I wipe out this register with 3 ohm, the current continues to flow on the other two register, and so is this. If I wipe out this, you can see that the current continues to flow in the other two registers. So clearly these three registers are connected in parallel, and to get the equivalent resistance, what we do, 1 over R is equal to 1 over R1, say 6 in this case, 1 over R2, which is 3, and 1 over R3, which is 1. Now if I take LCM, what it comes out to be 6. This is 1 times, this is 2 times, and this is how much? 6 times. So that results to give you 9 over 6. So this is 1 over R, not R, right? So this is 3 by 2 ohm. So, but R will be reciprocal of this, that is 2 over 3 ohm. So the correct answer is 2 over 3. B is the correct answer in this. In this question, a diagram is given over here, and they say that an electron is entering in the region of a magnetic field. So this representing a magnetic field. This is the electron which is moving in this direction, that is from east to west. Now further, it's given that the magnetic field direction is into the page, okay, and the direction of the deflection of the electron. Okay, what we know, deflection means we have to find out the force in which the force is acting on the electron. So we'll be applying Fleming's left hand rule over here. So for that, what you have to think that the direction of current is taken opposite to the flow of electron. So electron is moving in this direction. That means the current is moving opposite to this. That means in this direction. And the magnetic field is pointing. So what you have to do is to stretch. I'll wait for you to stretch. Stretch your forefinger, the middle finger, and the thumb in such a way that your middle finger is pointing towards this direction, that is towards west, and rotate your hand in such a way that your forefinger is pointing towards the direction of this page, right? So what you will figure out that in this case, right, the thumb will be pointing in the upward direction. So the force is acting in this direction. So you should know that these things you should know that these are mutually perpendicular here. These are mutually perpendicular. So therefore, applying Fleming's left hand rule will figure out that the force is acting out of this page or in the upward direction. If I see the option, it is there. That is, this one is the correct option in this case. Now, confusion in this question is what? That magnetic field produced by the flow of a straight wire. This phenomenon was discovered by. So they're not talking about the rule which determines the direction of magnetic field. They're talking about the who was the first to observe that a current carrying conductor behaves like a magnet. In that case, the answer is Oster. So hence Christian Oster, I think in 1880, was the first person to observe that a current carrying conductor behaves like a magnet. But the confusion is that so many of you actually think that they are looking for, asking for the direction. The direction of magnetic field was given by Maxwell. That is, we know them as a Maxwell screw rule in a straight current carrying conductor. But over here, the correct answer is option C. The question is which three allotropes of the carbon do the following figure represent? So allotropes, you know, of carbon, that's diamond, graphite, and Buckminster fullerenes. What you have to remember that, okay, this is the structure of graphite. So I can see graphite is over here and here. And this being the structure of diamond, diamond is here. And this is Buckminster fullerenes. The Buckminster fullerenes is over here and here. So the correct option will be D. So allotropes are those which have the same chemical constituent, but they have different physical properties because the different arrangement of these atoms.